Let's take a moment and review all of the different measurements that we have done or calculated. Our distance or displacement is simply something that we measured, so there's no formula for that one. The symbol is d, or d with an arrow over it. All right, let's do speed. Speed or velocity is the v with the arrow over it. Acceleration, a. Force is a capital F. Momentum, lowercase p. Impulse, uppercase J. Work is a large or uppercase W, and energy is an uppercase E, and power is an uppercase P. Okay. Once again, the formula that we use to calculate these, there's no formula for distance. And I didn't put time on here. But speed or velocity, the most common one here, it's the change in distance over change in time. Acceleration is, I'm going to, just to create space, I'm not going to put the A equals. So this was delta D over delta T. This was delta V over delta T. Force is mass times acceleration. Momentum and impulse was the mass times the speed, and the impulse was the change in momentum. Work and energy, well, we had a couple different formulas there. We had potential energy. Let's put the potential mgh, or we had 1/2 mv squared. And our power was our work over change in time. I want to put in here our units that it's usually measured in. Distance is in meters. Speed and velocity, meters per second. Acceleration, meters per second squared. Force is in newtons. Impulse and momentum, kilogram, meters. It's mass times velocity, kilogram meters per second. Work was in joules, and power is in watts. I'm going to add one other column here. These are the fundamental units. Meters, meters per second squared. A newton is a kilogram times meters per second squared. This one is a kilogram meter per second. A joule was a kilogram meter squared per second squared, and a watt is a kilogram meter squared per second cube. Understanding your fundamental units and how they apply to the actual unit, the SI unit, can be very helpful in solving problems.